Hey students, we are on Notes Unit 6, Day 3. This is one of my favorite set of notes to do because we're learning three different types of problems, but they all kind of use the same pattern to work them out. Everything is still done by cross multiplying. So we're going to have three theorems. These theorems do show up a lot on the EOC, the state test that you have to take, and they're not hard to remember what to do. So we're just going to jump right into these. All right, so the first theorem that we're looking at is called the triangle proportionality theorem. We often call this the side splitter theorem. Okay. All right. So we've got this picture here. It kind of looks like some of the pictures that we had yesterday where we have the overlapping triangles. But the thing that is new is that we have these parallel lines. So if we have parallel lines, the theorem says if a line is parallel to one side of a triangle and intersects the other two sides, so if this line is parallel and intersecting the other two sides, then it divides the sides into segments of proportional lengths. So if it's proportional lengths, then we're able to solve by using proportions. So basically, if DE is parallel to AC, okay, segment DE, segment AC, then we have proportions that can happen. Now, to make this so easy for us in the classroom, rather than saying BD and DA and BE and EC, because that's a lot of letters, I'm going to put little letters here. So we're going to put an A representing this segment, a B representing this segment, a C representing this segment, and a D representing that segment. Those represent all of the little segments. And so if I have what this theorem says, then I can make a proportion. When we write down the proportion, as long as we're consistent, we're always going to get it right. And the way we're going to be consistent is I'm going to put A over B and C over D. So basically, I'm going to go either top over bottom. Whatever letter's on top goes over the one that's on the bottom, or I can go left over right. A over C equals B over D. That's what we're going to write down. So let's write down this way first. A over B equals C over D. Now, you cannot say A over B equals D over C. That's not consistent. Top over bottom, top over bottom. You can go bottom over top equals bottom over top. As long as you're consistent, it doesn't matter which one you put first. Okay, so this is one way we can get our answer. Or if I'm going to look at this way, I can say A over C, that's left over right, equals B over D, left over right. And again, I can go right over left, right over left. It doesn't matter. Now, the reason I have choices to work this out, look at what happens when I cross multiply. I'm always multiplying the A and the D, the A and the D, and the B and the C, and the B and the C. Okay? So if you follow this pattern where we go top over bottom or left over right each time, you're going to be able to get these right. We're not going to worry about the converse. Okay, now, because I feel pretty confident that you know how to cross multiply, I am not making you work out problems necessarily in the notes unless I want to just check for a couple of the problems, which I will. So for some of these, I'm just going to show you how to set it up, and we're going to write the answer. Okay, and if you don't trust me for the answer, you can try to work it out. Okay, so look at number 1. So, by the way that I set up a problem and the way that you set up a problem might be different, but again, because we can set them up, there's actually 4 different ways I could set this up and we can all get the same answer. You want to make sure that the answer is correct, and if it's not, then we've got to see how you set it up. So, the way I would set this up is I can go top over bottom, or I can go left over right. Okay, it doesn't matter. So let's go top over bottom. If I go 14 over x, then that would equal 12 over 15. And again, I know you know how to cross multiply. We would get x equals 17.5. Okay, but notice what I'm multiplying: the 14 and the 15 and the x and 12. Okay, so you guys should know how to do that. If I had set it up the other way, okay, now you do not have to show me multiple ways of setting up a problem. I'm just showing you in the notes. But if I said 14 over 12 equals x over 15, what it's doing is it's putting these in the different switching places, and we're still getting the same answer. Okay, it doesn't matter. All right, let me show you this one. So number 2, I'm going to go left over right. Now you got to kind of think of the picture like this. Actually, I'll go top over bottom, top over bottom. So you've got to kind of rearrange the picture to fit the picture up here if that's what you need to do. And I think having the point of the triangle at the top of your paper really makes it easier, and you can always go top over bottom equals top over bottom. So I'm going to say x over 18 equals 56 over 21. X over 18 equals 56 over 21. So I went this over this equals this over this. And as long as I'm consistent, I'm going to get it right. I could have also said x over 56 equals 18 over 21, and that would have given me the same answer. Anyways, this one would be x equals 48 if we worked it out. Okay. All right, question number 3. Now, we need to do the side splitter theorem. We need the little pieces. Okay, so when you see a problem like this, and we've got that 55 and the 45, I can't say 55 over 45 equals x over 36. That doesn't make sense because 55 represents the whole side over here, and I don't have that piece. That piece would actually be x plus 36 over here. Okay, if we added these two together. So I need that little piece. All we have to do is subtract these two because these two pieces are going to add to equal 55, and I get the 10. We are not using the 55 in our problem. Okay, so you can actually scribble that out, and we're using the 10. Okay, so I want you to show me how you would set this up and go ahead and work this one out. And this is going to be one of the questions that you answer to get credit on the notes. Okay, work this one out. Okay, let's see what you did. So again, I'm going to go x over 36 equals 10 over 45. I went top over bottom equals top over bottom. So let's cross multiply. 45x. 10 times 36 is 360. And then if I divide, we get x equals 8. So hopefully you got that one question right. All right, number 4. What number do you think would go right here? Okay, you said 21. You got it right. So there's going to be a 21 right here because 21 plus 6 equals 27. So this is how I would set this up again. You can say left over right equals left over right, or you can say top over bottom equals top over bottom. So I'm going to just kind of mix it up and go top over bottom. So if I said 7 over 6, I would put x over 21. Okay, and I'm going to double check this work real quick. So 7 times 21, and then divide by 6. My answer would be 24.5. Okay. All right, then we get to some problems. This is why we practiced on this 2 days ago with these polynomials, the binomials. Okay, so we're going to set this one up the same exact way that we've been doing the others. I can go left over right equals left over right, or top over bottom equals top over bottom. So I'm going to go 30 over 25. I went left over right this time because I mix it up all the time. So then that puts x plus 7 over 15. Okay. Now, remember the little shortcut that I told you? That if you have a number that fraction that reduces, it can give you smaller numbers. If you wanted to cross multiply with the 30, And with the 25, you can. There's nothing wrong with it. But I know that 30 and 25 are all divisible by 5. And so if I wanted easier numbers to deal with, I could reduce it. You can do that anytime you can reduce a fraction. It just gives you smaller numbers to deal with. You do not have to do that. You could cross multiply with the 30 and the 25. Okay, so I'm going to say 5 times x plus 7 equals 6 times 15. 5x plus 35, and then 6 times 15 is 90. 5x equals 55, subtract the 35, and we get x equals 11. Okay, well, guess what? You're going to do problem number 6. So go ahead and do problem number 6. We'll check your answer, work it all the way out to get your final answer. Okay, you can check your answer. Now you notice that I went ahead and reduced the fraction again to give me easier numbers because I didn't have to pick up my calculator at all to do this problem. You could have multiplied the 6 and you could have multiplied the 21 and you still would have had bigger numbers, but we would have had the same answer, x equals 9. Okay, so with the side splitter theorem, remember top over bottom, or left over right to get your work. And then make sure if you have the big side that's given to you that you subtract because you need the little pieces. Okay, next theorem. Actually, we have 3 application problems. Okay, so this next question, if you notice there's not an X in the problem. So the question is actually a yes or no. Okay, and it's asking, is this line parallel to this line? Well, basically, we need to set up our A over B equals C over D, cross multiply, and see what it gives us. These are actually really easy questions to do. Okay, so I'm trying to see if these two lines are parallel. So I'm going to put 11 over 15.4. So I put that over that, 10 over 14. If I cross multiplied and got the same numbers, then these sides are proportional, and then this would be a yes. Okay, so if I multiply 11 times 14, I get 154. 11 times 14 is 154, and then 10 times 15.4 is also 154. So what that means is yes, these lines are parallel. What would make them not parallel is if these proportions don't give you the same numbers. Okay, so number 8, I'm going to go left over right, left over right. 15 over 4 equals 18 over 5. And we're going to cross multiply. So 15 times 5 is 75. 18 times 4 is 72. So that means this is a no. Okay, they are not proportional. See how easy this is? Okay, number 9, I'm going to let you do. Your answer is going to be yes or no. Don't forget, what do you got to do right here? Okay, so go ahead and work this one out. We'll check it when I come back. Okay, so you should have had a 30 right here because if you subtract these, 54 minus 24 is 30. And then I went top over bottom equals top over bottom, cross multiplied, and I got 900 and 900. So that means, yes, these two lines are parallel. You do not have to put the parallel markings. I'm just showing you. That's what we're checking. But the answer is yes. The yes or no is your final answer. You have to have work to back it up to get credit for that answer. Okay, now the next theorem, these are going to be super easy. We're actually going to go a little bit quicker. It is called proportional parts and parallel lines. You have 3 parallel lines, and it says if 3 or more parallel lines intersect 2 transversals, then they cut off the transversals proportionally. This is really easy. Let's put an A, B, C, D. It's exactly what we did before. Okay, so if AB is parallel to CD, which is parallel to EF, Then the same thing that we had before, A over B equals C over D. Or the other ways that I showed you, left over right equals left over right, or top over bottom equals top over bottom. Remember, you can go this way and you can go this way. The only thing you can't do is diagonal. You can't say A over D equals C over B. No diagonal, okay? Vertically or horizontally setting up your problems. Okay, so we'll go quicker on this just to show you it's the same exact thing. I'm going to go 45 over 18 equals 52 over x. Cross multiply. See how easy that is? It's the same thing that we did before. It's just a different picture. Okay, go ahead and do number 11 for me and get your final answer. All right, x equals 35. Okay, so then on number 12, tell me again, what number would go right here? All right, if you said 14, you got that question right. We are not using the 32 in my work. I'm saying 27. I'm going to go left over right equals left over right. And we would get x equals 21. See how easy this is? You're going to fly right through this work. All right, what number would go here? We're going to subtract, and it's going to be a 64. I'm going to go top over bottom. Why did I go top over bottom? I don't know. I just decided to go top over bottom. Whoops, 31.5 over x. You can go top over bottom equals top over bottom, or left over right equals left over right. It does not matter. Sorry about that. That's a 5. So then if we cross multiplied, we get 72 for that answer. Okay, just giving you more practice with this. Okay, number 14, I'll set up for you. I'm going to go 24 over 18 equals 3x plus 1 over 12. What do you think I should do here? Should I use the big numbers or should I reduce? Well, I know that 6 goes into both of them. 6 goes into 24 4 times. 6 goes into 18 3 times. I think it's a lot easier to use the smaller numbers, but you don't have to. So if I said 4 times 12 equals 3 times 3x plus 1. 4 times 12 is 48. 9x, make sure you're distributing. This is what we're doing. 9x plus 3. I'm going to subtract 3, divide by 9, and you get x equals 5. This work should not be difficult for you. All right, number 15, do that one by yourself. Check your answer on the questions, and we'll see if you get it right. All right, did you get it right? Now this time I went top over bottom equals top over bottom. If you went left over right equals left over right, you could have reduced this fraction and had smaller numbers. Okay? All right, last page. Last theorem is the triangle angle bisector theorem. So this one looks a little different than the other two, but it's going to be the same setup. So what it says is if we have a triangle and this is an angle bisector, which means this angle equals this angle. This little angle equals this angle. And it says if an angle bisector in a triangle separates the opposite sides into two segments that are proportional, an angle bisector in a triangle separates the opposite sides into two segments that are proportional to the length of the other two sides. So what that means is these two sides here are proportional to these two sides. I'll show you how easy this is. We're going to put A over B and C over D. Okay, remember we can go top over bottom or we can go left over right. It's the same setup. You just have to have the angle bisector. Okay, let's put A over B equals C over D. Okay. Very simple. I'm going to go 12 over 4.8 equals 18 over x. 12 over 4.8, 18 over x. Cross multiply. Same setup. We can go top over bottom or left over right. Okay, now if your triangle is turned sideways and it helps you, turn it like this. I can go 54 over 40, x over 36. If that helps you, turn your triangle to where the point is at the top, and it should work out. Okay, so by the way, it did tell us right here, KM represents an angle bisector, even though it's not drawn in the pictures. This is an angle bisector. So I want to make sure that is clear to you guys because it's not drawn in the picture. All right, for this one, I would go 54 over 40 equals x over 36. There's lots of ways. You could say 40 over 54 equals 36 over x. 40 over 36 equals 54 over x. It doesn't matter. We're all going to be multiplying the same things. And we get x equals 48.6. Okay. All right, number 8. What about this? Okay, so remember, we're going to write this little note. That we can't do these problems unless we have the small parts. We're not using the 39 in our work over here, but I'm going to say 39 minus 15, and that's going to be a 24. Okay, go ahead and do that problem for me. Set it up, finish it. Remember, you're not using the 39 now. All right, so I went top over bottom equals top over bottom. X over 15 equals 36 over 24. If you went left over right, we still multiplied the same things. We still get the same numbers. We all should get x equals 22.5. Okay, all right, we're almost done. All right, now these two problems are the trickiest ones, okay, because there is a, actually number 10 is just like number 8, but number 9 is the trickiest one. So let's do number 10 first. Okay, so go ahead and do number 10. This will be the last one that I have you do for points for the questions. Do number 10 completely, remember, okay, and then we'll come back and check. All right, did you get it right? So I went top over bottom equals top over bottom. We did not use the 45 at all. I used the 27 and the 18. I subtracted to get the 18. Now that is really important to help us with question number 9. When I subtracted, I went 45 minus 27. This was on the outside, and this was on the inside. And what I mean by that, outside and inside. Biggest, this is the biggest, and this is the smallest. Okay, it's going to help us when we get up here to number 9. All right, so I need this to be represented by something, but there's an X out here. So just like we did here, where I said 39, which was on the outside, minus the 15, which was on the inside. And that gave me the number that was right there. Okay, for this one, what's on the outside? What's on the inside? Can I subtract 12 from x? No. So what I'm going to do is I'm going to take that, and it's going to be represented right here, x minus 12. I'm going to go ahead and tell you, in your homework, there's an x in here. So you're going to have a number minus x right here. Whatever's on the outside minus what's on the inside goes here. And we've shown that with numbers, and now we've shown it with variables. Okay, so to finish this problem, I'm going to go top over bottom. Top over bottom. And I'm not going to work this one out. We're just going to put the answer because I know you know how to do the math. Okay. All right, we're done. Be sure you go in and mark your notes as done, please, to get it off of your to-do list. And then we'll do the next worksheet in class the next day that I see you. Have a good day.